three types of limits. There are three types of limits. First one, two-sided limits. Second, left hand limits. And the last one, right hand limits. Okay. Then we come to see each kind of limits. Okay. The first one, two-sided limit. For example, today we learn, there's a two-sided limit. For example, the first one, right? Like when you say, when this is a function, right? But when you take the limit for both sides, when x equal to 4, okay? So then you can answer, this is a two-sided limit. Because when you write limit in this way, limit f of x, when x equal to c, okay, equal to L. This is a definition of limit, correct? Then, for example, this one, when you write limit of function when x equal to 4, this one we call two-sided limit. Because when we lead, we're gonna lead from the left hand limit and right hand limit and approach closer to 4. Okay, and then here the answer y equal to 2. But when we, for example, this one, if I say this one, right? For example, if I say this one approach to 4, we should use this example, approach to 4 positive. Okay, so if you have plus sign at the top here, we call this one is a right hand limits. Okay, then you can leave the value of limit. From the right hand, the plus sign represents right hand limits. So from the right hand, you see the graph. For example, this graph. From the right hand, that means from here down. From closer when x approach to 4. So when closer to here, to this one, then you make this one gonna be equal to 2. Okay. And at the same time, from if you say limit function of x when x equal to 4 negative. If you have negative side, then when you leave from the left hand side, leave the left hand limits from this graph closer like 3.9, 3.99, and 3.9999. We just learned all the example. So then you can answer this one equal to 4 also. So this limit from the left, right? From the left approach to 4 and from the right closer to 4. They make at the same point. This one should be equal to 2. Should be equal to 2. Okay. And then most of them equal. Okay. So then we can say this limit as exists. Okay. And this is the same idea. Okay. So like you see from this limit on x when limit 1 over, I write it down here. It's a limit of this one. Limit of 1 over x squared when x equal to 0. For example, we come back to this example. Okay? This example, if our limit 1 over x squared when x approach closer to 0. If we write this way on 0 here, doesn't have plus or minus sign. So this is called two-sided limit. But when you have sign, for example, you say negative on the top and minus sign on the top. This one we call left-hand side limit. Okay. But when you have plus sign here, we call right-hand limits. Then if limit 1 over x squared when x equal to 0 plus, that means from this graph, if you come to this graph, okay, this one belongs to this graph, this one belongs to this graph. So that means when approach plus, right? So that means you leave on your right hand side, have a new graph, we have this graph from the right hand side. So your x approach closer to 0 here. Okay, that means you can answer this one, limit of 1 over x when x approach to 0 plus, here equal to plus infinity, this one equal to plus infinity. Or you can say doesn't exist. Okay. At the same time, if you change this one become minus sign, you read this one also from the left, right? The graph happen from your left hand side or have our left hand limit. Then mean this graph. So x approach closer. I mean the graph x closer to 0. Closer but not equal. So it's closer. Now I will get idea about this. Come back to see this example, maybe then the more understanding. This graph, okay, this graph. So now if I say, I ask you about, like now we answer this graph, okay. Say if I ask you, say find the limit of function when our x approaches to zero. Okay, you see this graph, how many functions we have? We have 1, 2, 3, and 1 dot, 4 functions. Okay, so if I ask you say limit of function when x approaches to 0, what this answer gonna be? So that means you see we don't have plus or minus sign at the top here, right? We don't have plus or minus sign here. So that means you have to read both sides. That means you have to read the two-sided limits. So from the left and from the right. Okay. So then you read from the left here. This from the left it means happen this graph. And also sorry, close to 0 here. So from this graph, right? That means this graph and this graph. This from the left hand limit and this right hand limit. So that means from this graph you read closer to x approach to 0 and the right hand side also. Then they met at this point. Then this answer equal to 4. Okay. Now if I change my equation, this one. If I say I ask you limit f of x when x approach to plus x. That means you have to read x approach to 0, right? Plus sign, that means it's a right hand limits. So you see approach to 0, what graph is on this picture. So that means this graph closer from the right hand, right? From the right hand limit. So this one lead closer, x closer to 0. So they make at this point. So this also the equation equal to 4. Okay, that's why when x approach to 0, and then you see if I change this one, become negative. Right? Then you leave your graph from the left. So this one is closer. Then you make at this point. So your y equal to 4. Then limit f of x when x approach to 0 does exist. Because both sides from the left and from the right, they are equal value. This is equal to 4. That means you leave the value of y. Okay, don't forget, when we try to find the answer of limit, we find the value of y. Okay, now we try more example for this. We still use the same graph, this graph, okay? If I say, I change to limit of function f of x when x approach to negative 1. When x approach to negative 1. Okay, when x approach to negative 1, you see negative 1, that means this graph, right? That means you have to leave from the left, right? Because no sign plus minus on the top here. So you're going to leave the two sides of limit. So then you see from the left hand side, from the right hand side here, that means what graph we have. That means this graph, right? The approach closer to, when x closer to 1, that means this graph happens. So when from the right hand side, right? In this case, you have to lead to things. Maybe I delete this one now. So then in this one, you will lead when you must lead from the left, right? Limit f of x when our x approach to negative 1 minus, and limit f of x when our x approach to negative 1 plus. Okay, so have the negative sign at the top here. So then we have to find out graph when have any graph happen when x approach closer to -1. So this means from the left we don't have any graph. So this one no solution. This one can say doesn't exist. Sorry. Okay, and then if you reform limit f of x when x approach to -1 plus, then you reform from the right side. Okay, so when you reform here, when closer to x, closer to -1, our y is what? Here, right? 5. So you answer this one equal to 4. This one will equal to 4. So you see, when the question asks you limit f of x when x approach to -1, you have to leave both sides from left and from right and see they have the same value of y. But in this case, you see, it doesn't. They are not equal. So then we can answer the whole thing for this limit. For this limit doesn't exist because this one not equal. This one not equal. So it doesn't exist. Okay, everyone get it? Now, if I continue, as you say, if limit, I erase this one. If I ask you if limit f of limit function f of x when x at close to 2, see that? When x approach to 2, that means you have to leave both sides, correct? It's a 2. This is a two-sided limits. So then you see when x approach to 2, x equal to 2 is here, right? So then from the left you have this graph, and from the right you have this graph. So this graph from the left approach closer to, and this closer to the right hand side. So both of them will meet at this point, which is equal to y, so 3. So you answer this one equal to 3. Okay. Now, how about this dot? If only one dot, limit doesn't exist. Okay. If only one dot, limit doesn't exist. Limit will exist only when we have any graph from the left and from the right approach to the point. But this only one dot, so limit doesn't exist. Unless I ask you to say f of x, okay, when x equal to 2, then you can answer, if you answer at this point, right, this exists, this have solution, that means equal to 7. So f of function f of x when x equal to 2 will equal to 7 when you ask about function. But when you ask when the limit will equal to 3 here. Okay. That's okay, everyone understand, right? So next one, maybe the last one now. Limit f of x when x up close to 5 negative. See, right now we negative, right? That's the left hand limits. So how you answer? Left, right? So you see, up close to 5, that means 5 here. We have graph from the left, right? And this from the right. So we answer here from the left. From the it's a left hand limit, and from the left hand limit. So this means this x up closer to 5, right? So then this at this point. So you answer here. Answer here. So this is equal to 6. Okay. But then if I ask you say this one become plus, right? And you let this one. If I ask you if limit of function f of x when x approach to 5 plus, so you have to look in here, x approach to 5, what graph happen? Just only this one. So x approach closer to 5. And this one 5 closer to at the point, this is equal to 8. Okay, so then you see the first time I have, but we have limit f of x when x up close to 5 negative. 5 negative, that means from this side, right, so equal to 6, the first time we got. Then you see these two limit doesn't equal. So we can say limit f of x when x equal to 5 doesn't exist. Because from the left and from the right, they have the different value of y. Okay. Any question? I think so far today we learn, we know how to find out the limit. Okay, limits of function is really related more like dynamic problems. Will different from the previous year we learned, because like example, this one at the beginning we say you will answer when x equal to 4. When x equal to 4 here, you will answer is undefined, but limits have the answer, like today we learned. Okay, I think it's gonna be, that's all for today about the limit. Then I will give you the handout. I will post it in school website, or maybe in the email. I will tell you soon after then, and then you can start to practice the question. I will tell you detail what question and what pages you need to do, and tell you how you're gonna send to me. And you have any question, you can comment or write it down or lie to me. We have line group, we have email or the school website. Okay, but anyway, try to do your best. Try to do all the questions what I assigned to do. Okay, so I think that's all for today. Thank you for your joy our class today. Okay, and see you next class. Thank you. Bye bye.